So our lesson is exploration of linear inequalities. Linear inequalities. So we just spent the last unit talking about linear equations, like y equals mx plus b. Now we're going to talk about y is less than or equal to mx plus b, or y is greater than mx plus b, and see what that looks like. Okay? So vocabulary, new things you need to know. One word is boundary. Boundary is a line or curve separating one part of a plane from another. Okay? The boundary in the graph below is the line with the equation y equals 5x plus 5. Okay? So if we look at our picture here, this boundary line is y equals 5x plus 5. That's just the boundary line. It should make sense. There should be an intercept, a y-intercept at 5, and the slope should be 5. So if we can find this point, it would be over, up 5 over 1 to get to the next one, or down 1, 2, 3, 4, 5 over 1 to get to the next point, etc. Okay, so that should make sense with that flat line. A boundary that is a line divides a plane into two, what we call half planes. Okay, so this boundary line here separates the plane into the red part and the white part. Okay, so that's why it's called a boundary. It cuts the plane into two parts. Everybody good with that? Just cutting the plane into two parts. Okay. A half plane then. A half plane, it's a region in a plane consisting of all points on one side of a boundary. Okay? All the points on one side of a boundary. So every line divides the plane, it lies it into two half planes. Okay? So every line will be like a dividing boundary, and then half plane on one side, half plane on the other. Inequality. We already know that from what we just learned. It's a statement that compares two quantities or expressions that are not equal. For instance, we know 8 is greater than 2, and 5 is less than 2 times 3, which is 6. 5 is less than 6. An inequality contains one of these signs. So either a less than or equal to, a greater than, or a greater than or equal to. A linear inequality is an inequality whose graph is a half plane with a linear boundary. So this, what we're showing here, is the linear inequality y is less than or equal to 5x plus 5. That's what's shaded in red. And you guys, it'll be shaded in gray, I guess. Red here. Okay? So here's our boundary line. And this half plane is the half plane y is less than 5x plus 5. So here's my 5x plus 5 line. Underneath it, if you think about it that way, would be all the points, not numbers, but points that are less than 5x plus 5 that satisfy that inequality. Okay? So let's take a number, for example, an ordered pair for example here. Okay? What would that ordered pair be? Well, do we know its x value and its y value? Yeah. What are they? 2 and 4. So this is the x and this is the y. So if we put the y as 4, it should be less than 5 times 2, because x is 2, plus 5. And that would be 15. 5 times 2 plus 5. So is 4 less than 15? Yes. So any point I pick in here is going to have that property. It's going to satisfy this inequality. It's going to be less than 5x plus 5. Now what happens if I picked a boundary point? For instance, this boundary point is 0 and 5. Everyone agree that that boundary point there is 0 and 5? Does it satisfy y is less than 5x plus 5? Let's check. 5 is less than 5 times 0 plus 5. They're equal. So see how this is dashed? A dashed line shows the boundary points aren't included. Dashed line, boundary points are not included. Not included. If it was a solid line, then the boundary points would be included, and that would be if there was a less than or equal to sign there. Okay? So a dashed line, boundary points aren't included. They're not solutions. Solid line, boundary points do satisfy. Okay? And basically you can think of as dashed line is going to be if it's greater than or less than, and a solid line is going to be if it's greater than or equal to or less than or equal to. Okay? So a dashed line is strictly greater than or strictly less than. A solid line on the boundary is going to mean greater than or equal to or less than or equal to. So, vocabulary. So we know what a boundary is. We know what a half plane is. We know what an inequality is. A linear inequality, our example that we've used was y is less than 5x plus 5. That's an example of a linear inequality. Okay, so we're going to start off. Graph y equals 2 on Desmos. So you guys do it on your phone. I'll model it here. Desmos. So pick the graphing calculator version. Graphing calculator. So I want to draw a y equals 2. Does everyone see that that's a horizontal line along 2? So you want to type in y equals 2 in your graphing calculator. Shows you a horizontal line, slope is 0. So let's copy that onto our graph. Y equals 2. So this line here is y equals 2. Sketch the graph on the grid to the right, we did. Where are the points with a y value greater than 2 located on your graph? Above, okay, above the line y equals 2. Sketch a few of these points. So a few points that are greater than 2. Anything above here, it can be like in a halfway. Anything above here is greater, has a greater y value than 2. Okay? Its y value is greater than 2. Anything up here. You can get really close, but not touching. Any of these points have a y value greater than 2. So it should make sense to us. Any of those points have a y value greater than 2. All right, so then if we go to the next board here, we're going to graph y is greater than 2 on Desmos. So I'm just going to go back to my phone, and I'm going to change the equals to a greater than. So I take up my calculator, y is greater than, oh, sorry, got to get rid of the equals. Y is greater than 2, and look what it shows us. Y is greater than 2. Why is the line dashed? Why is the boundary line dashed instead of solid? Right, so y is strictly greater than 2, not greater than or equal to 2. Okay, so any y value that's along the line y equals 2, the y value is 2. Okay, is 2 greater than 2? No. So it's not included. The boundary line is not included in this case. So if we go back to our graph, I want to dash this. Okay, we'll turn up the tree. Is to just take my eraser and make this a dash line. And then I'm going to take a highlighter and I'm going to shade in everything above that dash line. So here's my highlighter. And I'm going to shade in everything above that dash line. And this represents the inequality y is greater than 2, strictly greater than 2. Okay? So that's the inequality y is greater than 2. It includes all these points we drew on, as well as everything in between, like all these points that we didn't draw on. Okay, anything up here has a y value greater than 2. All right, so compare this graph. How are the graphs different? The plane above, or the half plane, that's better, the half plane above the boundary line is colored in or shaded in. The graph y equals 2 is the boundary and the shaded area is a half plane. Okay, they tell us that there. So the line y equals 2 is a boundary and the shaded area is called a half plane. All right, what does the shaded area of the graph represent? All of the points that have a y value greater than 2. So there's an infinite number of those points. So the shaded area represents every single point you could think of that has a y value greater than 2. Every single point you can think of that has a y value greater than 2. That's what the shaded part represents. And then here it didn't talk about y is the boundary dash, so let's add a C here. Y is the boundary line dash. Instead of being solid. So y is the boundary line dash instead of being solid. So look at our picture again. Why is this line here dashed instead of being solid? Because because we don't include points on the boundary line, because those points are not greater than, their y values aren't greater than 2. Okay? And the reason is, points on the boundary line are not included because their y value is not greater than 2. Not greater than 2. Okay, so why is the boundary line dashed for y is greater than 2? It's because the points on the boundary line are not included because their y values are not greater than 2. Okay? So dashed line, boundary points are not included. Solid line, boundary points would be included. Okay? So what do you think the only thing that would change is if I were to put y equals greater than or equal to 2 into decimals? What's the only thing that's going to change about this picture? The only thing that should change about the picture from y is greater than 2 to y is greater than or equal to 2. What would be the only thing that you think would change? The boundary line? Instead of being dashed, it would be solid. So the only difference between those two is whether we have a solid boundary line or a dashed boundary line. So this is solid boundary, and this one would be dashed boundary. Okay, because any points along the boundary line are equal to 2, so they are considered greater than or equal to 2. So all those points are included now, instead of being excluded. All right, so let's write that down here. So,
well, can you staff please put out your morning bin right now? So I'll take you staff please put your morning bins outside the door.
first, I just want to show you that that's true. So we'll go to decimals here. So y is, so I'm going to switch that greater than to greater than or equal to 2, and you see the boundary line is solid. Okay, boundary line is now solid. All right, so are the points on the boundary line solutions? Yes, they are. Okay, they have a y value, which means y value is greater than or equal to 2 or equal to 2. How does changing the sign from greater than to greater than or equal to change the solution of the inequality? So boundary line changes from dashed to solid. Boundary line changes from dashed to solid. Thanks, Ella. I'll take you to the office. In the office? Okay, so now let's try on Desmos typing this in to a little box there. So on your phone, go to Desmos and type in y is greater than 2x plus 4. Any predictions on what it would look like before we even type it in? First of all, tell me whether the boundary line is going to be dashed or solid. Y is greater than 2x plus 4. Would the boundary line be dashed because it's just greater than, not greater than or equal to? Okay, and I know that the line 2x plus 4, here's 4, right? And then 2, slope of 2 means up 2 over 1, up 2 over 1, so it's going to look something like this, dashed. Now, what sign am I going to be coloring in if it's greater than 2x plus 4? The y value is greater than 2x plus the right side, that's less than, that's under the line. Greater than is the left, okay? Above. So think below, above. Greater than is above, less than is below. So this is, our prediction is it's going to look like this. Now let's go on to Desmos and see what it looks like. Okay. So y is greater than 2x plus 4. So I just need to add an, oh no, I have to change that to strictly greater than. Greater than 2x plus 4. And that was our prediction, right? So we have a dotted boundary line, and we've colored in everything above the line, okay? And that means the y value for all these points is going to be greater than 2x plus 4, which is kind of a hard thing to think about. So let's think about this point here. This point here is -7, +2. And we're thinking about the y value being greater than 2 times x plus 4. So our y value here is 2. So we're hoping 2 is going to end up being greater than 2 times -7 plus 4. So 2 is going to end up being greater than -10. Is that true? Yes. So the y value is greater than 2 times the x value plus 4. For every single point here, that's going to be the case. The y value is going to be bigger than 2 times x plus 4. Okay? The y value is going to be bigger than 2 times x plus 4. Yes? Kind of catching on? Okay. All right, let's go back to our... Okay, so how will the graph look different if you typed greater than or equal to instead of greater than? Anyone have a prediction? You just change this greater than to greater than or equal to? What's the only difference going to be? Yep, solid boundary line. Only difference. Check your answer in Desmos. We can go for it. I will do that. So if we think the only change is going to be, it's going to become a solid boundary line. So greater than or equal to 2x plus 4. Yep, that's the only thing that changed, solid boundary line. All right, how will the graph look if you typed in less than or equal to instead of greater than? Less than or equal to. Where's the shading going to be? Opposite side. So the shading is going to be down on this half plane. And is the bounded line going to be solid or dashed? Less than or equal to?
Oh, solid.
Solid. Good. Okay, so we're going to have how it look different. Solid boundary. And shade is below instead of above. Okay, so solid boundary, and we're going to be shaded below instead of above. Paul, go to the side stand, please. Okay, consider the graph of y as less than -3x minus 5. What is the equation of the boundary line, I should say? What is the equation of the boundary line of this inequality? We're just talking about the boundary line. What would its equation be? Y equals -3x minus 5. Okay, that would be the boundary line if you were drawing it yourself. Okay, Now, before you join the points, you have to decide if it's going to be a dashed line or a solid line. Which one? Dashed line or solid line? Dash. Which side of the boundary line is going to be shaded, do you think? Y is less than negative 3x minus 5. Above the line or below the line? Below. Okay, so when we do this on decimals, we're expecting the boundary line to be negative 3x minus 5. We expect it to be dashed, and we expect it to be shaded below that line. So let's check on decimals here. Y is less than negative 3x minus 5. So we have a dashed boundary line which we expected. That's the line. Let me get rid of this. That's the line negative 3x minus 5. So there's our minus 5, our initial value or our y-intercept. And then negative 3 means a down 3 over 1 or up 3 left 1, which is true. Okay, so it's following the right pattern. And it's shaded below it, not above it. Just like we predicted. Very good. Okay. All right, back to this. All right, next. So graph the following inequality on the grids below and then check our answers using decimals. Okay, so the first thing to do, step 1, is you draw the boundary line. So step 1 is to draw the boundary line. So the boundary line, we just replace whatever inequality sign is here with an equal sign. So we have to draw y equals negative x plus 6, which we learned how to do in the last unit. Okay? So who knows how to draw the line y equals negative x plus 6? Where does it start on the y-axis? Yep, 6. Awesome. And then what's the slope number? -1, which is my rise over my run. So I fill a 1 in here. And that slope means down 1, right 1, down 1, right 1. Down 1, right 1, down 1, right 1. Okay, so I've drawn my boundary line. Before I decide whether, before I join the points, I have to decide if it's going to be dashed or solid. So step 2 is dashed or solid. And I heard solid, that's because the equal sign's included. Okay, so I get my ruler out and I draw a solid boundary line. Solid boundary line. Step 3, you do your shading. And then you have to decide whether it's going to be above or below. Above or below. So in this case, am I going to shade above or below? Above, because it's greater than or equal to. So I get my highlighter out and I shade above. And now I've just drawn the inequality, y is greater than or equal to negative x plus 6. Okay, so use these 3 steps. So I'm seeing dashed lines, so starting at -8. And then my slope is 4, is my rise over my run, which means up 4, right 1. And then I'm going to dash my line. Nope, undo. Should be able to put a dash line here. Dash. Red. Yep. Okay, so I've drawn my boundary line and I decided it was dashed. Now shading, above or below that line? Below because it's less than. So I get my highlighter out now. And I shade below. Okay, so 3 steps. Draw the boundary line, decide if it's dashed or solid, shade above or below. Okay, these ones are a bit different because what did we do in order to draw these lines? Who remembers? We don't just by looking at it know M and B. Instead, we looked at it as the 2 numbers have to add up to 5. So our boundary line is x plus y equals 5. And the way we did this is we found 2 values that added up to 5. An x and a y that add up to 5. Anyone got a pair of numbers that add up to 5? 4 and 1. Another pair of numbers that add up to 5? 3 and 2. Another pair? You need 3 to start drawing your line. So one more pair that adds to 5? 1 and 4. Okay, so let's plot those. 4 and 1. 3 and 2. 1 and 4. Okay, so now we want to make that into a line. Is that line going to be solid or dashed? I can see the pattern is, so I can fill more in there. Is the line going to be solid or dashed? Solid, good. Solid line. So I drew my boundary line, I knew it was solid. Am I going to shade it below the line or above the line? Below. And so every point in here, it means if you take the x value and add the y value, it's going to be either 5 or less than 5. Okay, and we can pick a random point to try here, like -2, 1. Is -2 plus 1 less than or equal to 5? Yes, it is. Okay, check. So you can always test yourself and make sure you shaded the right area. Can you sit down, please, Paul? All right, how about x minus y is greater than... Okay, Josh, 2 numbers that when you subtract them, the answer is 3. X minus what? Yeah, 6 and 3. Someone got another pair of numbers that when you subtract them, you get 3. Yep. 4 and 1. 4 minus 1 is 3. And one more? 5 minus 2 is 3. Okay, so let's plot them. So 6, 3, 4, 1, 5, 2. All right, we can definitely see our pattern. So step 1, draw your boundary line. Step 2, decide whether it's dashed or solid. Dash because it's just strictly greater than, great. So I'm going to pick a line style out here. And my color. So it's a dashed boundary line. And then am I going to shade above or below? That's the 3rd step. Below? This says greater than. Should be above, okay, because it's greater than. X minus y is greater than 3? That's weird. That's true. Why is it like that? Whereas this one, 1, 1. Not true. Maybe you have to have them in y equals mx plus b form. Let's see what x plus b is about. So if we get y by itself here, we would have to add y to both sides. And then subtract 3 from both sides. Ah, so when y is by itself, no, when y is by itself, I need the eraser. So see, I can switch sides, but the arrow is pointing at the y. Y is less than x minus 3. So another way of saying x minus y is greater than 3 is saying y is less than x minus 3. Which has the same boundary line dash, but it's below. So it has to be y by itself on this side in order for it to work with inequalities. Thanks, Dallas. So you always have to have y by itself for inequalities. So we got the right boundary line, but we have to shade below because we have to have the y by itself. So I think that's going to change our other one too, is it not? What was the other one, the first one? X plus y equals 5, was it? Okay, so let's see. So if we start out with x plus y equals 5, we want y by itself. Oh, sorry, what was it, greater than 5? Greater than or equal to 5? So we subtract x. Sorry. Well, x plus y is less than or equal to 5. Okay. X plus y is less than or equal to 5. Okay. So that's going to be 5 less than or equal to 5 minus x. Let's see what that one looks like. Y is less than or equal to 5 minus x. And that is the same, is it not? Yeah. Okay, so it's that, we call it the sneaky negative. Sneaky negative. This one beat the teacher, so it's a level 4 plus 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 plus. So it should be shaded below. And we said that that was because when we rearrange this to get y by itself, we add y to both sides. And then we subtract 3 on both sides. And then we switch sides, so y, the arrow points at the y, is less than x minus 3. So this was wrong. Write the correct inequality to describe the picture. So these ones are a bit different. First, you have to figure out the equation of the boundary line. So that's going to be step one. Figure out equation of boundary line. The first thing you do is figure out the equation of the boundary line. In order to do that, you need to know what M is and what B is from the graph. B is the y-intercept. It's the easiest one to find. So what's that? 5. B is 5. Perfect. And now we have to figure out our slope. Okay, so I find another point that's on a corner, and I'm going down 1, right 1, down 1, right 1. So what does that mean my slope is?
1 over 1 or 1?
Negative 1 over that because I'm going down, but yes, negative 1. Okay? Or you can draw a big right triangle if you want, like this, where your rise is negative 5 and your run is positive 5. Slope is rise over run. Slope is negative 1. Okay? So once you figured out the equation of your boundary line, so we always know it follows y equals mx plus b. So we put the negative 1 in front of the x plus the 5. That's step 1. 2. Now we determine the inequality. So we have to replace the equal sign with the correct inequality. Replace the equal sign here with the correct inequality. So what inequality would I put there to show where it's shaded? And to show that the boundary line is solid. Which inequality would go in that box to show that we have a solid boundary line and to show where it's been shaded? What do you think? Equals would just be the line, so but there is an equals because it's a solid line. Greater than or equal to or less than or equal to? Less than or equal to, below or equal. Good. Okay, so same thing for this one. Here's our picture. So step 1 is to get the equation of the boundary line. And step 2 is to get the correct inequality. So to get the equation of the boundary line, you always need to figure out what the slope number is and what the y-intercept is. So y-intercept, you go along your y-axis till you get to the point on the boundary line. Does everyone see it's at 0 on the y-axis? The boundary line crosses the y-axis at 0. And what's the slope, Paul?
I don't know, but can I go to the wash after this lesson?
If you can tell me how to get the slope here.
You add a bunch of numbers.
No?
Subtract.
No? How do you figure out the slope?
Do I say the answer?
No?
Yes.
Paul, how do you figure out the slope from the graph?
You look at it and that's,
No?
that's what I did. See that one's got blue.
What's the formula?
I don't know, why that's the distance?
Because you should know, we just finished a whole unit on how to find slope.
Here we go.
We used one formula the whole time. It was the same formula over and over and over again.
They're like 10 x,
M equals
x,
something over something. They're words. They're words, Paul.
I don't know, I don't know.
They start with R, both of them.
Run,
Rise over run. So how does that help me with this?
I don't know.
So you have to draw a right triangle, so we find another corner. So there's another corner. Is this a positive sloping line? Just the boundary line, Paul, don't worry about the shape.
Yeah, it's positive.
It's positive. Okay, so our rise is 3, agreed?
Yeah, and the run is like 5, I think.
6.
6.
So our rise over run is 3 over 6. Does that reduce?
Yes.
2?
I would say different.
It does.
It does?
Yeah, 3/6 is the same as 1/2, right? 3 over 6 is the same as 1/2. So now we know the equation of our boundary line. If we follow y equals mx plus b, is going to be y equals a half x. And do I need to show plus 0? No. Okay? So step 1, get the equation of the boundary line. Step 2, figure out the correct inequality. So I know I'm going to have y on one side and a half x on the other. What goes in the box to show what's shaded? What inequality goes in the box to show what's being shaded? Greater than or equal to, because it's a solid boundary line, right? Because it's a solid boundary line, greater than or equal to. Greater than because it's above, equal to because there's a solid boundary. Okay, and the last one. So finding the equation of the boundary line, I would like to see if where's the y-intercept. So the b is 2. M is the rise over the run. So I have to make a right triangle. Here maybe. So that's negative 1, 2, 3. Remember, it's a negative over 1. So the slope is just negative 3, okay? And then, so my equation of my line is y equals negative 3x plus 2. So that's this is all my boundary line work. And now I want to do my inequality. So it's going to be y, and then I have to figure out what to put in the box, negative 3x plus 2, to show what shading and whether my boundary line is dashed or solid. So is it shaded above the line or below the line? Below, so that's less than. Is the boundary line dashed or solid? Dashed, so I don't put in or equal to. Okay? All right, guys, good job. So we're gonna do some games, Desmos games.